Hello, am I audible?
Yeah.
If people are still joining, let's wait for some 3 to 4 minutes. After that, we will start. Hello, hello, am I audible?
Yes, sir.
Okay, okay. Why is there very less people have joined? Okay, so how many of you have attended the last session? Last. No one?
I have attended, sir.
Okay. Okay, so is my screen visible to all of you? No?
Come again, sir.
Yeah. Okay. Okay, so in the last session, we were at the topic what is the mean, right? What is the median and mod and all, right? And so these all things we have discussed in the previous session. Also, we had discussed if suppose I have some old data set and I want to add a constant value to the all the observation of old data set, right? Then what will be the mean of new data set? So it will be nothing, just old mean plus that constant value. Okay, am I right? So same for in case of median also. If I want to add a constant to all the observations, then my new median or median of new data set will be old median plus who is it? Josh. Hello.
Yes, sir.
Who is this name Josh? Yeah. So and new median was will be old median plus C. And same happened with the mod also, right? What will be new mod of? New mod will be nothing but old mod plus C, right? So this concept was clear to everyone, or any doubt in this? Okay. So why we are using this one? New mean equal to, I mean, why we are going to use this property? Okay, let's take an example. Suppose in a class, okay, there are some 50 or 60 students, and teacher gave the marks to each student, and average marks of that class is, let's say, 60. Okay, for example. Yeah, yeah. Someone is asking something. Okay, so after some time, suppose there was some scenario like suppose one question was wrong and teacher decided to give 3 marks to all the students, right? Then and after that you wanted you are interested to know the what will be the new mean. Then for such scenario, this property is very useful. I mean, rather than going to add 3 to marks of each student, then calculating the mean, it's good to use directly mean of the, I mean, mean old mean plus that constant value. Okay, is this clear to everyone? So let's take one example. Let's say suppose you have data set 1, 2, 3, 4, and 5. So what will be the mean for this data set? It's a 15 divided by 5. So it's a nothing but 3. Correct? And what is the median? Median will be 3. Now, suppose I want to add a constant C, let's say as 3. So what will be my new data set? New data set will be 3. If I want to add 3 to all of this, so 3, 5, and 6, 7, and 8. Then now tell me what is the mean?
3 plus 3. Old mean plus constant.
That's okay. Okay. Just tell me mean of this one. That's me. We are going to use property. So here it will be 538 plus 6, 14, 7, 21, 8. I think there's something wrong.
So instead of 3, 4 should be there. First one.
Yeah, it will be 4. Yeah, yeah. Then it will be 30 divided by 5, right? So it will be 6. So now what is the 6? This is 3 plus 3, right? So this means 3 plus this constant value, correct or not? Same will happen with the median. So median of this data set will be 6, correct? That, which is nothing but 3 plus 3. So it's nothing but old median plus that constant value, correct or not? So same, suppose I wanted to multiply by a constant, then suppose I wanted to multiply by this 3. Then what will be my new data set? It will be 3, right? So 3, 6, 9, 12, and 15, correct? Now what will be the mean for this data set? If you add, it will be 30, 45 divided by 5, right? So it's a 9, correct? So it's a nothing but 3 into 3. So this is the constant and this is the mean of old data set, or you can say old mean, correct? Same happen with median. Median is here 9. So 3 into 3. So this is the old median into that constant value, correct? So same property is applicable to with the mod also. So here I'm interested to add the constant. Now if I wanted to multiply by a constant, let's say that constant is C in general, then mean of my new data set will be what? Old mean into that constant, and median of new data set will be, or you can interpret as new median equal to old median into that constant, and same with the mod. So mod will be new mod equal to old mod plus into C. Okay. So as you can see in this example we got, right? Okay. Okay. So these three concepts are clear. Okay. So next topic is see, these all topics of is nothing but measures of your central tendencies, right? Now next concept is measures of dispersion. So why we are interested in? So what is the meaning of dispersion or variability and all? So basically, we wanted to know how much variability is there in our data set, any kind of data set, right? So see, you have data set, right? You know what is the central value. Central value means mean, median, mod. As per the situation, you have to use the, I mean, you have to prefer whether you can use the mean or median and mod. Now comes next question arises: how much variability is there in data set? How much dispersion is there in my data set? Or what is the no? I mean, these all are different terminology. So basically, measures of dispersion are first one is the range. Okay. Next is the variance and standard deviation. Okay. Another we will discuss IQR later. Now, so this what is the range basically? Anybody? Range of any data set. So range of any data set is nothing but maximum value
Maximum value.
minus minimum value, right? That's all. Suppose I have data set 1, 2, 3, 4, and 5. So what will the range? Range is 5 minus 1, 4, right? Now tell me one more thing. Suppose I have data set 1, 2, 3, 4. Let's say instead of 5, I have 500. Then what is the range now? Range will be
499.
499, right? So can you see there is a significant change due to an extreme value? Yes or no?
Yes.
Correct. So that means what? Can I say range is very sensitive to outliers?
Yes.
Did you get the idea? Okay. Now, this is something range. Range is very simple. I mean, range of, if you are ask about what is the range of a data set, just subtract the maximum value minus the minimum value. That's all. Okay. Next concept is variance. Okay. So basically, there are two types of variance. One is called population variance and one is called the sample variance. So basically, what is the variance? This tells us the how much variability is in our data set. But if you say, okay, let me introduce that population variance and sample variance, you will get clear idea. So what is basically population variance? Anybody? Yes, no?
Am I audible?
Yeah, yeah.
So population variation depends upon the density of the living being there.
Okay. So basically,
audible
why?
now?
Okay. Yeah, yeah. So basically, see, measure of dispersion is range also, variance also. Why we are moving range to variance? Any idea? See, range includes only two observations of your data set, right? To test the variability, correct? But if you comes to the variance, or there are two formula, population variance and sample variance. Variance, one important thing, good thing is about variance is it includes all the observations of data set, basically. Okay. Now, what is the called population variance? Nothing but it's a 1 upon n, summation of I is equal to 1 to n, xi, xi means how many observations you have, let's say n observations you have, minus x bar squared. So this x bar is nothing but mean. Okay. Now, if you come to the sample variance, so there is only one difference. It's nothing but denominator will change as n minus 1. Rest of the things is the same. So this is, I mean, it will be clearly mentioned whether you have to find out the sample variance or population variance. So this is just a only difference. Why we are using the denominator n minus 1 and all. So for this particular stats one, it's not important. So you can just keep in your mind. I mean, it's a something unbiasedness property and all. You will study it later. But so this is just a concept of population variance and sample variance. So as I told you, variance includes all the observation of my data set. Now, if you see clearly what we are getting through the variance, anybody can tell me what we are observing through the variance? Yes, no? Feel free to say, okay, don't think if it's something is wrong, we can discuss it on. Hello, am I audible, right, everyone?
Yes, sir. It
Okay, so
is
you tell me,
not
right?
dependent. It
Yeah.
is not like very much change will not happen if we change any one value.
Okay.
Like in range, if there
No,
is a
no, no.
change in
No, variance is also will affect by the outliers. I will tell you why. Because mean is also very sensitive to outliers, right? So here we are using mean. So basically, variance what tells us? It tells us what is the difference, how much variability is there of each observation from its mean. Are you getting what we are doing? We are taking difference of the each observation from its mean. Okay. So this is something tells us the variance. It tells us the how much variability, how much spreadness is there of each observation from its mean value. Okay. Now, if you let's discuss that concept. If I wanted to add a constant, okay, and multiplied by a constant, then what will happen to the my variance? Okay. Now, so in general, population variance, there is a notation we are denoting at sigma square, and for sample square, it's a small s square. Just a notation. Okay. So now, if I want to add a constant and or multiply by a constant, let's say I wanted to add a constant. So what is the sigma square? I'm going to consider population variance here. You can take sample variance also. Now, so if I want to add, so first of all, tell me, this is the population variance formula, correct? If I want to add a constant to each observation, what I will get? I will get xi plus c, correct? Minus, if I want to add a constant to each observation, then my new mean will be what? My mean will be updated by old mean plus that constant or not? Yes, no?
Yes, sir.
Okay. So basically what we are doing, okay, let me introduce that yi as xi plus c. Then what will be the y bar? It will be x bar plus c or not? Y you can treat as new observations. Okay. So let me denote it yi minus y bar. I'm going to see what will be the effect of adding a constant to my old observation. Now, what is the y bar here? It is nothing but x bar plus c. Are you getting?
Yes, sir.
So it will be I is equal to 1 to n xi plus c minus x bar minus c whole square. So this will c will get cancelled out. So what I got? I is equal to 1 to n xi minus x bar square. This is the sigma square. So what is this? This again I got the same old variance. Correct? So there will not affect by adding a constant to all the observations on the variance. Correct? So that means I can say simply new variance is same as the old variance. Is it true? Okay.
Yes, sir.
Now, if I want to multiply it by a constant, if want to multiply by a constant, then what will the yi? Yi is observations of new after multiply by the constant. So it will be xi times c, correct? And what will the y bar? It will be x bar times c. I mean, new mean equal to old mean plus old mean into c. Now come to the sigma square new. So it will be 1 upon n summation I is equal to 1 to n yi minus y bar square. It will be 1 upon n summation I to n. What is the yi? Yi xi times c minus x bar times c whole square. Correct? So it will be 1 upon n summation I to n. If you see, I can take c as a common. So it will be c square. Okay, if I will take square of it. So now if you see, I will get c squared times 1 upon n summation I to n xi minus x bar whole square. So it's a c square into what is this quantity? Old variance or not?
Yes, sir.
So if I will multiply it by a constant to all the observations, then my new variance will be square of that constant times old variance. Is it clear to everyone? Now, next concept is standard deviation. Okay. So what
Yeah.
is this standard
You are
deviation?
able.
What is this standard deviation?
Square root
Square
of
root of variance.
Square root of the variance. So why we are taking square root of the variance? If I have variance, right? Then what's the need of standard deviation? So we are just taking the square root of it. But why? What's the need? It will, yeah, please go ahead. Yeah. Hello. Yeah, you're not audible. Can you? I think there is some disturbance from your back. Can you read it? Okay, so why we are using this standard deviation? There is one important thing called units, right? Why? Because suppose your observations is about let's say age of some persons, okay, then your variance will be, what will be the unit of your variance? Let's say you are getting 144 or let's say some 40 year square something. I mean, I'm just assuming random data, right? Correct. So your variance will be in unit square, I mean year square or not? Yes, no?
Yes, sir.
So
Yes.
what if I will take square root
Yes,
of
sir.
this? if I will take square root of this, then what I will get? I will get
Same
some
unit.
value in unit year, right? Unit will be same, right? So it will be easy for us to compare in the same unit rather than going to year square, right? So that's why standard deviation comes into the picture. In a way, formula is the same. So basically, what will be the population standard deviation? So it's nothing but square root of 1 upon n summation I to n xi minus x bar square and sample standard deviation. I'm writing STD for standard deviation. Square root of 1 upon n minus 1 summation I to n xi minus x bar, the same thing. Now,
Sir, one question, sir.
yeah, please go.
So why we are deducting one number in the sample standard
Yeah,
deviation?
that's the actually I told you. So for this particular course, you can just keep in your mind. So there is some history behind it. I mean, you'll study it later. Why we are using n minus 1? So if you study later, so there is called concept of biasness and biasness. So if I will take expected value of s square, it should be sigma square. So it will be equal to sigma square only when we are going to take n minus 1 and all, right? And some degree of freedom concept is involved. Okay. So for this particular foundational level of course, so we are not going to in that depth. We are just using the formula. Okay.
So okay. So then as of now, just we
Yeah.
remember these things.
Yeah.
There is
That's
no
it.
need to remember the concept again.
No. So there is actually in stats 2 and all, you will study MLF and all, you will get the why we are using this n minus. Okay.
Okay, sir.
So as you can see here, since there is, if I want to add by a constant, so my new variance was, okay, let me write down in terms of variance. So my new variance was equal to old variance, correct? So if I'm talking about in terms of standard deviation, then my new standard deviation will be what?
It would
Because
remain the same.
it will remain the same. Okay, the same thing, because by this property we can verify this, because it's just nothing but square root of this. Okay. Now if I want to multiply it by a constant c, then what I got? New variance equal to c square into old variance, correct? Then if what about standard deviation? Then my new standard deviation will be c
C
times
into
old
old
standard.
variance.
Okay, old standard deviation. Okay, so this things is clear to everyone.
Yes, sir.
Okay, now, so I think next topic. Okay, so you will be able to calculate this variance and standard deviation, right? Suppose any data set you have given, let's say 1, 2, 3, 4, and 5, and I ask what is the population variance. So just draw a table, just make 1, 2, 3, 4, and 5. So this is your exercise. So just compute x bar, which is 3. So compute xi minus x bar. Okay, it will be minus 2, minus 1, 0, 1, and 2. Then xi minus x bar square, and then add all the things and divide by n minus 1 if I ask sample variance, and divide by n with population. Okay, you'll be able to do it. Right? It's a simple mathematics, right? Okay, so far so good.
Yes, sir.
So next is percentiles, right? So anyone can tell me what is the percentile? So basically, percentile is nothing but it's a value on a scale of 100. I mean that which indicates basically percent of a distribution below or equal to it. Meaning, let's say I'm saying I wanted to compute the 25 percentile. So what is the meaning of this? So this is nothing but 25% of the observations are below it, and remaining 75% observation will be above it. Let's say I'm saying 65 percentile. Okay. So what will the meaning of this? So 65 percentile means let's say this is the value of this is the value where 65%. So that means 65% of the observations will be below it, or remaining 35% observation will be above it. Okay, so is this clear? What is the meaning of the percentile? Hello.
Can you please repeat it, sir?
Okay, so meaning of percentile means, suppose I'm saying 25 percentile of a data, right? I mean, it's a scale of 100. It's a scale on 100, right? So means, suppose I'm saying 25 percentile. So that means, suppose this is the observation 25%. That means 25% of the observations will be below or equal to this observation, and remaining 75% observation will be above this. Suppose I'm saying 65 percentile is this one. Suppose this is the one and this is the 100. Then 65% of the observations will be below or equal to this observation, and remaining 35 will be above it. Got it? Suppose in JEE exam, and if you know GRE exam and all, so there you got percentile things, right? Suppose some student got 85 percentile. So what is the meaning of this one 85 percentile? Anybody?
85% are below from that student.
Yeah. Suppose this student is A. So 80. Suppose he got 85 percentile in that exam. So that means 85% of the students are got the marks below this student, and remaining 50%, 15% students are got the marks above this. That is the meaning of percentile. Is this okay?
Yes,
Yeah.
sir.
Okay. So now how we can compute the percentile in general? So basically, for compute the percentile, first step is we have to arrange the data in ascending order, right? Correct. And next step is, after arranging the data in ascending order, what we have to do? We have to compute the value of n into, value of n into p. What is n? N is how many observations in your data set, and p is the which percentile you wanted to compute. So this value of n into p will be maybe an integer value or a decimal value. It's possible, right? See, suppose n is 5 and you wanted to compute 25 percentile, so the value of p will be 0.25. So value of np you will get 1.25, right? So same, you can find out the value in integer. Now, if your value of np is in decimal, then what will be your percentile value from your data sets? So if your value of np is in decimal, then just is highest value than this value. Let's say 1.25 you are getting. So that means second observation. I mean, that's the next smallest integer. Okay, next smallest integer greater than this value of np. Okay. See, greater than 1.25, greater than 3 is also greater than, right? Third observation, fourth observation. But we have to consider next smallest integer, which is greater than. Okay. We will take as a percentile. If value of np is coming out to be in integer, then we will take the average of npth observation and np plus 1th observation. Right? That's the procedure to calculate the percentile. Okay. Let's take one example. Let's say I have data set 11, 12, 11, some 13, okay, 15, and let's say 22, something like that. Now, what is the first step? I have to arrange in ascending order, right? So it will be 11, 12, 13, 15, and 22, correct? Next is we have to calculate the value of n into p. What is n? N is here 5. Yes or no? Suppose I wanted to compute the what is the 25th percentile of this data set. So value of p will be here 0.25. I mean, this is nothing but 25%. Right? I'm interested to compute this. So next step is compute the value of n into p. So what will the 5 into 0.25? It's nothing but 1.25. Yes or no? So
Yes.
1.25. So we have to take, since it's in decimal, so we have to take the next smallest integer. So what will be next smallest integer? 2, right? So that means we have to take the second observation. So what is the second observation? It's the 12 of the sorted data. So here 12 is nothing but your 25th percentile of your data. Did you get it?
Yes, sir.
Suppose I am interested to know, let's say I wanted to compute the let's say 40th percentile. Okay, I wanted to know this. So what will be value of p? P will be 0.40. So what will be value of n into p? 5 into 0.40, which will be 2. Since it's in integer, right? It's not in decimal. Then what we have to take? We have to take the average of npth observation and np plus 1th observation. So it's a 2. So that means we have to take the average of second observation and third observation, correct? So what is the second observation? 12. What is the third observation? 13. So what will be the 40th percent? So 12 plus 13 divided by 2, it's 25 divided by 2, which is nothing but 12.5. Is this clear percentile?
Yes, sir.
Sir, but 12.5 is not a value in the in our list. So are decimals permitted for percentiles?
Yeah. It's percentile. See, it's a small data set. That's why we are getting. Okay. See, sometimes percentile is some small observation. Some whenever you will go in real life, you will get large data set, right?
Yes.
Excuse me, sir.
Yeah, please.
Regarding the 5 percentile, can you explain how did we take the second observation?
Okay, so what procedure says we have to compute the n into p, right? So n is 5, p is 0.25, so I got 1.25, correct?
Yes.
So when your value of np is in decimal, then we have to take the next smallest integer. Next smallest integer, not previous one. So what will be the next smallest integer? Second, right?
Yes.
See, 1.25, its next integer will be 2, right? Even though 3 are integer, 4 are there, but we have to take the smallest one, not the greatest. Got it?
A kind of round off. Okay.
Round off. Basically, suppose you got 1.98, even though you have to take 2, if you 1.19, even though you have to take 2.
Yes.
Got it?
Thank you, sir.
Yeah.
Thank you so much.
So next concept is called quartiles. Okay, next fundile, quartiles. So what is the quartiles? Anyone? What quartiles does or what quartiles tells us?
There are 4 quartiles. First is 25th percentile, 50th percentile, and 75th percentile. And fourth is
Okay, so basically it divides my data set into 4 equal parts. Okay, suppose this is the first part, this is the second part, this is the third part. Okay, but somewhat here scaling is not that much equal, so just treat it all the parts are equal. So it divides the, so it's a 1/4, right? Basically, meaning of quartiles means 1/4, right? So this first thing's called Q1, this is called Q2, this is called Q3. Since it's divides my data set in 4 equal parts, that means this will be 25%, correct? This will be 25%. This part will be 25%. This part will be 25%. This is okay? Now, so what is the Q2 here? This see, I can say Q1 is normally it's we are treating as first quartile. Okay, we are treating as first quartile, and it covers the 25% of my data set. What about Q2? Q2 called second quartile. Okay, and it's also it covers it's 50% of data set, so it's called the median also. Would you agree with me? Because it divides my data set in 2 equal parts. Here it's 50% of the data and remaining 50% of that. That's the median does, right? Yes or no?
yes, sir.
So same for Q3. Q3 is called third quartile basically, and this Q3 covers the 75% of the data. That's okay. This is something called the quartiles. If I wanted to compute the Q1 of my data set, then how will I will compute? So I will say n is, let's say, for previous observation. What was the observation? Let me take this ascending order data 11, 12, 13, 15, and 22. So I had 11, 12, 13, 15, and 22. So n was 5. So to find out the Q1, what is the 25 percentile of my data set? So P is 0.25, right? So, and we got NP as 1.25, and we have to take the, since it's in decimal, I will take the second observation, correct? So second observation is 12. So what is the Q1? Q1 is 12, right? Yes, no?
Yes, sir.
What about 50th percentile? N is 5, P is 0.50. So what will be value of NP? 5 into 0.5. So what is 2.5, right? So that means we have to take the third observation. That's correct. So third observation. So what is the third observation? This is 13. So I can say Q2 is 13, and you can directly by seeing the observation, you can say 13 is the median, right? It's the medial observation, which it divides my data set in two equal parts, correct? So what about Q3? N is 5. For Q3, I told you it covers the 75% of the data set, right? So P will be what? 0.75. So value of NP will be 5 into 0.75. That means what? 3.75, right? So 3.75, it's in decimal. Then I have to take the next smallest integer, which is fourth observation. So what is the fourth observation? Which is 50. So Q3 of my this particular data set is 15. Okay. So I got Q1 as 12, Q3 as 15. Okay. The next concept is called IQR basically, which is nothing but it's a full form of this is interquartile range. So interquartile range is defined as nothing but your IQR is defined as nothing but Q3 minus Q1. So for this particular data set, Q3 is 15, Q1 is 12. So it tells you IQR of your data set is 3. It's also measure of dispersion, as I told you initially. Okay. Next concept called outliers.
One question, sir.
Sorry.
One question. This
Yeah.
why we take Q3 to Q1? Is it also would be same as Q4 minus Q2? Will it be same?
No. Not Q4. What is the Q4? Q4 is nothing but, right? See, we have defined the quartiles. So basically, it divides my data set in 4 equal parts. Okay. So Q1 covers the 25% of my data set. Q2 covers the 50% of my data set, and Q3. And this is the maximum value, and this is the minimum value. Let me draw one plot that will clear you. Basically, one plot is called box plot. So what it denotes actually? So this is something called box plot. So this upper thing denote the maximum value of your data set. This denotes the minimum value of data set, and this denotes the Q1, and this denotes the Q3. So basically, what IQR says, what is the difference between this interquartile? We have Q1, Q2, Q3. So it tells us what is the difference between Q3 and Q1. That's all. No Q2, Q4, right? And Q2 can vary as per my data set. It's doesn't mean Q2 will be exactly in between. It may be in between. As per my data set, it can be here or it can be here somewhere. Okay. So IQR is nothing but difference between this two values, Q3 minus. This is called the IQR.
Okay, thank you.
Okay. Yeah. So next concept is basically outliers. Okay. So far so good for everyone, right?
Yes, sir.
Okay. So now, how I can find out whether is there any outliers in my data set? Is there any outliers present in my data set or not? So there is one formula to identify whether outliers are there or not. So it's nothing but your observation. If is there outliers says outliers would be less than Q1 minus 1.5 times of IQR. This is the one formula. Okay. and you have to check whether is there any observation which is less than this quantity, or is there any observation which is greater than this quantity, Q3 plus 1.5 times of IQR. Okay, if there is any observation which is less than this quantity, we can treat that observation as outliers. And if there is any observation which is greater than this quantity, I'm going to treat as outlier. So basically, this box plot, this from this region to this region, maximum to minimum, is free from outlier. I mean, basically, if outliers is there, then it will be presented like this. Your box plot will be, I mean, it will look like that. So this means, I mean, after minimum value, if there is any observation, you will treat as outliers, and you, if there is observation which are above that maximum value, you will treat as outliers. Okay, so this is something called, I mean, how I can identify the outliers. Let's do for this particular example itself, whether you can see whether outliers is there or not in my data set. So I had data set 11, 12, 13, 15, and 22. So Q1 of my data set was what? 12. Q3 was 15, and IQR was 3, right? Now let's compute this part, this quantity. So what is the value of Q1 minus 1.5 times of IQR, right? So what is the Q1? 12 minus 1.5 times of 3, what you will get? 12 minus 4.5. Yes, no?
Yes.
sir.
So what is the
7.5.
difference?
It will be
Sorry?
7.5.
Yeah, that is the 7.5, right? Now, so I have I got this value as 7.5, correct? Now, tell me one more thing. Now, let's compute the another quantity also. Q3 plus 1.5 times of IQR. So what is the Q3? 15 plus 4.5, right?
Yes, sir.
Okay. So what will be this value? 19.5? Yes or no?
Yes, sir.
So can you tell me, is there any observation which is less than this quantity in my data set?
No.
No. Is there any observation which is greater than this quantity?
Yes.
Which is, so
22.
this is, so dash 22 will be treated as outlier for this particular. Okay, since it's a small data set, basically this is the one of the method to know whether outlier is there in your data set or not. Okay, is this clear?
Sir, is there any logic to use 1.5? Is there?
Actually, this formula, I mean, so something derivation is involved behind it.
Okay.
So it's I mean, if you want to save the time, so you can just go with the formula for.
Okay. Okay. Thank you.
So logic is there. Everything is involved logic actually. Okay, basically this, if I'm not wrong, so basically this minimum value is treated as something. I think it's a Q1 minus 1.5 times of IQR, if I'm not wrong. Okay. So basically this is the formula we can for this particular course and all. This formula is treated as to identify what is the basically this things minimum value is nothing but basically Q1 minus 1.5 times of IQR, and this you can treat as Q3 plus 1.5 times of IQR. For this formula, let's not go there in the derivation and all. Just you can keep me. Okay. So idea is clear to everyone. This IQR, percentile, and quartiles, outliers, and all.
Yes, sir.
Everyone. Okay. So I think we have covered the concept of week 3, so that now we can move to the week 4. Yes, no?
Yes.
Okay, so far we have done, see, in week 1 and all, we discussed if I have data, right, or if I have variable and all, so how many types, what are the 2 kinds of my data set? Anyone?
Categorical and numerical.
Categorical and numerical, right? And what is the categorical? Categorical data is nothing but if I'm not able to perform any meaningful mathematical operation, I can code in numbers. Let's say I'm coding female as 1, male as 0. I can code in numbers, but there is not any meaningful mathematical operation I can perform. Correct? And numerical value is something, it's quantitative in nature, and I'm able to perform meaningful mathematical operation on it. Now, in week 3, we saw some measure of central tendency, measure of dispersion, and all quartiles and all on numerical data. Now, we'll see in this next video some how I can say we'll explore much about categorical variable. Before going to that, anyone can tell me what is the meaning of association of two variables? How you will say two variables are associated?
They are related in any form.
Okay.
So if there is a change in one, the other also gets changed. So there is a
Correct.
relation.
So if change in one variable, right, will affect the change in another variable. Correct. That is the simple meaning of association. I will say simply, it's the variables. Two variables are associated, or basically I can say if I have information about one variable, then it provides the information about second variable. Now we'll see whether I can find out or association between two categorical variable or not, right? That might be a question, right? So association between two categorical variables. Now, how we can see, there is one method called row relative frequency and column relative frequency. For that, first criteria is we have to make the contingency table. What is the contingency table? Basically, it's nothing but let me draw that table. It will give you clear idea. So basically, I have two categorical variable. One is owning a phone or not. Okay. And another, so is it categorical variable or not? It will be only two answers, right? Yes or no, correct? And let's say gender, which has again two category. I'm taking female and male, right? So it's a categorical variable, right? Do you agree with me?
Yes, sir.
Now, I'm interested to know whether these two are associated with each other or not. So suppose I have some data set. I'm taking the data set from which ma'am has taken. So ownership of a phone. So it has two category. Let's say it's a yes and no. Another is variable is gender, and which is female and male. So this is something you are going to arrange your data set in a table format. Now, so basically, suppose there are something 34 female owning a phone, and 10 are not owning a phone, and there 42 are male owning a phone, and 14 did not own the phone. So this is something called your contingency table. You are just arranging the data. Okay. What is meaning of this 10? Means there are 10 female who do not own the phone. I mean, you can cross check with the row and column. Now, let's do the row total and column total. What is the row total? It's nothing but 44. What is the column total? 56. So what is the grand total? 100, right? If you see, it's 76 and it's a 24. If you see grand total from here also, it's coming out to be 100. Now, this is something we are considering as a contingency table. Now, what is the row? Okay, before going to that, tell me what is the relative frequency we have done? Anybody? Relative frequency was frequency divided by total, right? Total number of observations. Yes or no?
Yes, sir.
Right. Now, here I'm referring the word row relative frequency. So what I will do, row relative frequency is nothing but I'm going to consider corresponding to row. So what is the frequency for this case? 34. And what is the total row total? 44. correct? So what will be the relative frequency for this? It will be 34 divided by 44. Yes or no? Are you getting? Hello? Everyone is getting, right? Or
No, sir.
okay.
Yes, sir.
So,
Yes.
so basically, relative frequency is nothing but we have done in week 2. You can rewatch also. So it's a frequency divided by total observations, right? Now here I'm referring the row relative frequency. So I will go with each row, right? So in the first row, what is the frequency? 34, right? Frequency means how much time it occurs. So 34, what is the row total? 44, right? So what will be row relative frequency for this observation? It will be 34 divided by 44. Frequency divided by total. Same for this, 10 divided by 44. Okay. Now for male category, it will be 42 divided by 56 and 14 divided by 56. Is it okay?
Yes, sir.
Now for the grand total column, if you see, you will get 76 divided by 100 and 24 divided by 100. Correct? Yes. Is it clear? I mean, how I'm going to proceed?
Yes.
Now, let's convert into percentage. So for going into percentage, you have to just multiply it by 100, right? So there's not something a big deal. Let's multiply it by 100 to each observation. So what I will get from here? So female, male. It's a yes, no. Okay. So it's a female. So 34 divided by 44 divided by 100 will be something. It will compute it. It's 77 point something 27%, right? And for no, it is coming out to be 22.73. And so let me compute this 42 divided by 56, 75, and 14 divided by 56, 25. Okay. And grand total, it's 76%. And so now what the method says and how I can compute this, how I can find whether these two variables are associated or not. So for this, we have to see whether row relative frequencies. So rule says if the row relative frequencies or the column relative frequency, you can compute the, let me go with first. If row relative frequencies are approximately same for all the rows, then I will say variables are not associated. Is this clear? Then if all the row relative frequencies are approximately same. Okay, so now here you can see whether here all the row relative frequencies are approximately same or not. You can see it's a 76, 24. Let's compute the whole row. Correct? It's a 75, 25. It's a 77, 22. So there is not a significant change, right? It's a some approximately same, right? Yes, no?
Yes, sir.
Okay. You can see values of each row. So I will say variables are not associated. Okay. Let's draw one graph to be clear. So this is here I have computed with the row relative frequency, right? So you can go with the column relative frequency also. I mean, you can use either one. I mean, either you can compute row relative frequency or you can go with the column relative frequency. So in column relative frequency, what you can do? You can do 34 divided by 76, right? Column total. Are you getting me? And it will be 10 divided by 76. Similarly, it will be 42 divided by 76. Then 14 divided by 24. Are you getting?
Yes.
Okay, so you can go with either method, doesn't matter. Okay, you can go and compute row relative frequency or column relative frequency. Now, so here you can see all the row relative frequencies are approximately same. I will say variables are not associated. I will say variables are associated, categorical variables are associated if all the row relative frequency are not same. Okay, let me draw one graph called it's called stacked bar chart actually. That will be helpful very okay. 77, 20. Okay. So what 100% stacked bar chart says, you have to draw the 100% bar graph. Okay, this is X, let's say not X. So for, let's say this is for female and this is the male, and here is denoting the percentage for ownership and all. Okay. So for female, let me draw a bar. So in 100%, so we are treating all the 100%. It's a 100% basically from 0 to 100, and it's for male. Okay. Now tell me, I'm denoting red color. I'm going to use the red color for not owning the phone. So what is the percentage for not owning the phone? Female 22.73, right? So let's say 22.73 is coming about approximately here. Okay. And for female, what is the percentage of not owning a phone? 25%, right? If it's 22.6, let's say 25 is somewhat here. Okay. Are you agreeing with me? Now, I'm going to use the green color for ownership of the phone. So remaining part is ownership of the phone. Yes or no? Remaining percentage. Now tell me, one of you told me what is the meaning of association of two variables. If change in one variable gives the information about change in another variable. Now, if I'm going to change from this variable, in this variable, I mean gender variable, female to male, is there significant change from ownership of the phone? Yes, no? They looks like approximately same, right? This is not a significant change.
Yes, sir.
Correct?
Yes, sir.
So what you will
Yes,
say?
sir.
You can simply say these two variables are not associated. Okay. When I will say these two are associated, let me draw another one. Okay. Suppose for a random data set, I'm just treating this female and male category. Okay. For some random data set. Okay. Suppose let's say marks, in terms of marks, whether marks has been affected or not, something like that. Suppose for female, okay, let's say this ownership of phone also. So let's say this part is not is owning the phone. Okay, green thing is denoting ownership of phone. Right? Now for male, let's say this is. For red, this percentage did not owning the phone, and now this percentage is ownership of the phone. Now tell me, if I'm going to change in one variable, then is there any change in another variable? Yes? No? Are you
Yes.
getting?
Yes.
So that means what? I will say these two variables are associated. So that means if row relative frequencies, as I told you, if row relative frequencies are not same for all the rows, then I will say variables are associated. If row relative frequencies are approximately same for all the rows, then I will say variables are not associated. You can go with the column relative frequency or row relative frequency in which you are interested. It doesn't matter. Okay. So this is clear association between two categorical variables.
Yes.
Okay. Now let's move to the, since we saw the association between two categorical variables, next concept is association between two numerical variables. Okay. So for that, I mean, whether two numerical variables are associated or not. So for that, we'll see covariance. Okay. That concept is called covariance. Okay. So covariance basically is defined for the two variables, and it tells us the strength of the linear association between two numerical variables. Okay. Now covariance defined for two variables. So basically covariance for between x comma y. Okay, is defined at, let's say, I'm going to consider for, similarly as we had defined population variance, sample variance, so here we can simply define population covariance. So let's say population covariance is defined as nothing but 1 upon n, summation I is equal to 1 to n, for one variable xi minus x bar. Here is for two variables, so yi minus y bar. So two different numerical variables. Now if you will replace yi as xi, basically covariance x comma x, then what I will get? I will get 1 upon n summation I to n xi minus x bar, right, whole square, which is nothing but variance of x, correct? So basically covariance defined for like this. So this is for the population covariance. What about sample covariance? So nothing but as usual 1 upon n minus 1 summation I to n xi minus x bar into yi minus y bar. So you can compute the covariance, right, easily. Suppose xi is given to you, let's say some age of person is some data, and yi, let's say weight or height of person is given to you. So you can compute, right, xi minus x bar and yi minus y bar, right? Will you be able to do it? It's a simple calculation, right? I mean, some observations are given to you. You can compute x bar, then xi minus x bar. Some observations of yi given to you. You can compute y bar and then yi minus y bar, and you can proceed similarly like this. Okay. So this is called something very population covariance and sample covariance. So basically, now comes to the one thing. Suppose xi, I told you, suppose it's in age, and yi is in, let's say, weight. So what will be the unit of your covariance? Anybody?
Age kilogram.
Year into kilogram, right?
Yeah.
Okay. Now the one problem arises here. It tells us basically strength of linear association between two variables. But how much strength are there? How much variable that those two variables are associated? Whether it's a positively. Okay. One more thing. Can you tell me whether this covariance can take value in negative? It can take, right? But variance can't take because it's a square. So suppose for a data set, let's say for this data set, you got covariance at, let's say, minus 72. For another data set, you computed and you got covariance at, let's say, 210. And for another data set, you got covariance as 100. And for another data set, you got covariance, let's say, 172, something like that. Suppose covariance tells us the strength of linear association, something like that. But what is the strength? I mean, how much they are associated, whether they are positive, I mean, strongly associated or weakly associated, we don't know, right? See, by seeing the value, we can't quantify how much association is there. Yes or no? You can't say this is less associated, this is high associated, or this is a high associated, right? Because there is not any lower limit to compare, or there is not any upper limit to compare. Yes or no? Are you agree with me? Hello. So are you getting the idea, this one, what I'm trying to say? Yes, no?
Can you please
Oh.
repeat, sir?
Sorry? Can you repeat?
Please repeat, sir.
Yeah, so you can ask at a time, right? So see, covariance basically says, it tells us the, I mean, we are not able to interpret how much association is there, right? How much strongly they are associated, how much weakly they are associated, right? By seeing the value, because it can take any value, it can take any negative value in like this, let's say minus 72, and any positive value. But by seeing the value, we are not able to see, we are not able to tell like how much association is there, right? You can't say 210 is strongly associated or 100 is strongly associated like that. Are you getting me? Because there is not any lower limit or not any upper limit to compare the things.
Yes.
Okay. It can take, let's say I'm saying covariance is coming out to be -150. Now tell me whether this is less associated or less, this is. No, we can't take, right? We can't say anything. Because this unit involves here also. So next concept called the correlation coefficient. What correlation coefficient says? It's nothing but covariance divided by standard deviation of x into standard deviation of y. Because s square we are denoting as variance, so it will be, you can, sx means a square root, so it's a standard deviation. Now, if you tell me here what was the unit of this covariance, year into kilogram, what will be the unit for standard deviation of x? It will be again year, right? And for y it will be kilogram. So it will get cancelled out basically. So why I'm trying to say that basically correlation is unitless measure, and we are denoting it as small r, and limit for this is -1 to 1. Now I will say if r is close to 1, I will say they are strongly positive associated, linearly associated, because it tells the linear association. If I will say value of r is close to -1, I will say they are strongly negatively linearly related. Are you getting me? If I will say r is 0, that means there is no linear association. Are you getting me? So because it has lower limit and upper limit for this correlation coefficient basically. Now, so I have formula of R as, okay, key idea is clear, this correlation coefficient.
Yes, sir.
Okay. Now, suppose in exam you are asking to compute the correlation coefficient between two variables. So just be clear with one thing. If you are using the sample correlation covariance formula in the numerator, then please use the sample standard deviation in the denominator. Otherwise, you can't use population covariance formula in the numerator and sample standard deviation in the denominator. It will give you wrong thing. Okay. Why? Suppose I'm going to use the population covariance, I will get 1 upon n summation of xi minus x bar, yi minus y bar, right? What about standard deviation? So you have to use the population standard deviation. If you are using the population one, I will tell you why. If it is the 1 upon n summation of xi minus x bar square, right? Then square root of 1 upon n summation of yi minus y bar square. So if you see, 1 by n will get cancelled out, right? Correct? So I'm getting the value of r as summation of I to n xi minus x bar into yi minus y bar divided by square root of summation I to n xi minus x bar square and square root of summation yi minus y bar, or you can directly use this formula, no problem. Okay. Yeah, I told you for population and sample. Suppose I'm going to use sample thing, so you have to use the sample in numerator as well as in denominator. Why? Because of it will be, suppose I'm going to n minus 1. It will be n minus 1 and it will be n minus 1. Again, it will get cancelled out, and at the end, I will get this formula of correlation coefficient. Is it clear to so far? Is it okay for everyone?
Yes.
Yes, sir.
So there are things, see, these things can take value, in negative, in positive also, but as it is close to 1, you can say strong and positive linear relationship. If it's close to 0, you will say absence of linear relationship. If it's close to -1, you will say strong and negative linear relationship. But be clear with this, covariance and correlation only tells us the linear association between two variables. Okay. Is this clear for everyone?
Yes, sir.
Okay. So next thing is that suppose, okay, will you be able to solve the questions, right? It's nothing but some xi minus x bar y minus y bar, right? Simple calculation, right? You are familiar with these notations, right? These are the observations. These are the mean. This is the mean of first observation. This is the observation of second variable, and this is the mean of the second variable. Okay. Will you able to do it? Yes, no? I'm
Yes,
hoping you guys are okay. Yeah. So far we have discussed association between two categorical variables, right? Yes or no? And we discussed association between two numerical variables also.
yes.
Now, what about if I want to know how I can find the association between one categorical variable and one numerical variable? Is there any way to do this? Hello, are you familiar with this? Is there any way? So there is one method called, I'm hoping you have watched all the lecture video, right?
Now takes
Okay, how many lectures video you guys have done? I mean, these topics I think you have covered, right? This point by serial correlation coefficient and all. So yeah, you can say yes, no, something like that. Because otherwise, only then I will be able to know, yeah, you are getting or not.
No, sir.
Otherwise, I will assume that you people are knowing. Okay?
no,
No,
sir,
sir.
but we are able to follow you. That's fine.
Okay, so you have not watched this one?
No, sir.
No, sir.
Okay. So please, I think exam is on 3rd of September. Okay. Only 10 days. So yeah, so this
Yes.
method, yeah, so we start. So basically, association between one categorical variable and one numerical variable I wanted to know. So for this, one method called point by serial correlation coefficient. Okay. What is that? I will tell you. So point by serial correlation coefficient. So here I'm interested to know find the one association between one categorical variable and one numerical variable. So what point by serial correlation coefficient? So formula for this is RPB. PB means point by serial, is nothing but, so we can denote, formula is y bar naught. I will tell you what is the interpretation of all the notices. Y bar 1 divided by sigma x into square root of P naught into P1. Okay. So what is the meaning of y bar naught and y bar 1? Since I'm going to take one categorical variable, and this categorical variable will have two category. I mean, it's a dichotomous variable. Only two category, kind of yes, no, female, male, like this. Only two category will be, and one numerical variable. So in that two categorical variable, I will label one categorical variable as 0 and one categorical variable as 1. Okay. So that's, and we have to find out the y bar naught, I mean, mean of that variables associated with 0 and 1 for 1 similarly. And sigma x denotes the population standard deviation. Okay. And in the lecture, ma'am has used small sx, but that's the mistake here there. But it's a sigma x. You have to use the population standard deviation. Now, what is the P naught? P naught is nothing but ratio of n naught divided by n, means what is the total number of observation and what is the, how many observations are there with coded with 0. Similarly, P1 is nothing but n1 divided by n, and we have to find out this. And one another formula is nothing but sometimes we are mentioning absolute point by serial. So which is nothing but we have to take like RPB is nothing but modulus of y bar naught minus y bar 1. Formula is same, just absolute value. Why? Because sometimes happen, suppose value of y bar naught is less and value of y bar 1 is high, then you will get the value in negative. That's not a problem, but we prefer this absolute one. But notation is same. Let's say I'm considering the one categorical variable as I'm going to take here as a gender. Okay. And this has two categories, female and female. And another numerical variable I'm going to take as marks. Okay. Marks is the numerical variable, right? Now, so gender is the one categorical variable. So let's say this has female, male, male, female, female, and male. Okay. And suppose marks. What is the marks? Let's say female 92, 80, 72, 58, and let's say 65. Let's say some 80, 48, something like that. These are marks of AutoCAD. Now, okay, it's clear. This is the one categorical variable. This is one numerical variable. So, right? Now, what point by serial formula says, RPB says nothing but y bar naught minus y bar 1 divided by sigma x into square root of p naught into p1. Right? Now, let's code female as 1 and male as 0. Okay. So if I'm coding female as 1, let's say this is 1, this is 1, this is 1. Okay, for our simplicity. And male as 0. Suppose this is 0, this is 0, this is 0. So far, so good. Just let me know whether are you getting or not. Okay. If you're not getting, if you will tell me, then I will be able to, yeah.
Getting, sir.
Okay. You're getting now. Next is, we have to find out the y bar naught. Okay. First of all, what is the p naught? P naught tells us, so let me use the, what P naught tells us? N naught divided by N. What is the total N here? 1, 2, 3, 4, 5, 6. What is the N naught? The number of observations which are coded with 0. So how many observations are coded with 0? 3. Right?
Yes, sir.
1, 2, 3. So it's a half. What is the P1? P1 is N1 divided by N. So total is 6. How many observations are coded with 1? 3. Half, right? So we got P naught, P1. Next concept is we have to compute the y bar naught. So what is the y bar naught? Tell me. So how will you compute the y bar naught? It's a average, right? So we have to take the average of the observations which are associated with 0. So that means we have to take the average of which observation we have to take average?
0 values.
Male.
Means 80
80
plus
72
plus
72 plus 48.
divide by what?
3.
3, right? Great. What about y bar 1? This
92
is 92 plus 58
plus
plus
65.
and divide by 3. You will get some value here, you will get some value. I'm not going to compute, I'm just going to give you idea, right? What is the population standard deviation? So since we can compute, see, mean we can compute only numerical variables. So will take marks of corresponding coded values, right? Population standard deviation, we can compute only of the numerical values. So population standard deviation, we have to compute of only of the this marks, right? So population standard deviation, we can compute and we'll get some value, right? It's nothing but 1/6 summation I to n this xi minus x bar square, you will get some value. So just put this value in the formula, put this value in the formula, put this value in the formula, and this value also, and this value, you will get the value for RPB. Okay. So basically there is one criteria says if your absolute value of point by serial is lies between 0.75 and 0.1, I will say these two variables are strongly influenced or strongly related to each other or strongly influenced to each other. That's all. Otherwise, it's not. I mean, it's not strongly related. Okay. Got it? Clear? Yeah. Yes, no? You got the idea, right? How you can compute the association between one categorical variable and one numerical variable.
Yes, sir.
Okay. Okay. So just give me 2 minutes. Then I will start the week 5 concept. Okay. Hello, am I audible?
Yes, sir.
Yes, sir.
Okay. So, are you familiar with the concept of counting principle, everyone? Just a simple mathematics. Yes, no.
Yes, sir.
So now we are going to start the week 5 onwards. So first concept in week 5 is called the counting principle. Okay. So it has two kind of counting principle. It's first one is called addition, and second one is multiplication rule of counting, right? What is that? I will tell you. Now, suppose I'm saying, let's say you are going to in a shop, okay, and in that shop there are let's say 3 milk chocolate, okay, and 4 dark chocolates. Okay, these two things are there. Now, suppose see, there is one scenario like you can purchase only one chocolate. Either you want to purchase one chocolate, either you can purchase milk chocolate or a dark chocolate. Tell me in how many ways you can purchase a chocolate? There are 3 milk chocolate, let's say M1, M2, M3, 4 dark chocolate, let's say D1, D2, D3, D4. In how many ways you can purchase a chocolate? Anyone? Yes, no, something like that.
7 ways.
7 ways, 7 ways.
7 ways, because it's a simple counting principle. You can purchase the let's say M1 chocolate, M2 chocolate, M3 chocolate, or D1 chocolate, or D2 chocolate, D3 chocolate. I mean, there are total 7 ways, right? So
Yes,
basically,
sir.
it's nothing but to find out the number of ways. Here, what I said, you can purchase either a scenario is you can purchase either a milk chocolate or I mean either I can purchase one milk chocolate or I can purchase one dark chocolate, right? That's the case. And what is the total number? Okay, now tell me, what is the total number of ways you can purchase a one milk chocolate? 3.
3.
What is the total number of you can purchase one dark chocolate? 4. What? It's a or. If it's or, that means we have to add. So it will be 7. Got it? So basically, in general, it says suppose there is one scenario or one event which is occurring in n1 ways, occurring in n2 number of ways, then in how many ways you can perform A or B, it will be n1 plus n2. Got it? Here n1 is 3, n2 is 4. Now, just let me manipulate the scenario. Suppose you can purchase one milk chocolate and one dark chocolate. Be clear with I'm using here and terminology. Okay. Now, in how many ways you can do? In how many ways you can purchase one milk chocolate and one dark chocolate?
$12 ways.
12 ways, right? What are those 12
Yes.
basically? Why? So if there is and, that means we have to multiply. Why we are going to multiply? Let's say I have M1, M2, M3, right? And D1, D2, D3, D4. Now I'm saying I have to purchase one milk chocolate and one dark chocolate. That means I can purchase M1, D1. I can purchase M1, D2, right? I can purchase M1, D3. I can purchase M1, D4 or not? Same, I can purchase M2, D1, M2, D2, M2, D3, M2, D4, right? Similarly, M3, D1, M3, D2, M3, D3, M3, D4, right? Are you getting? Yes, no?
Yes, sir.
Okay, so what are the scenario? Whether you can purchase like this, right? You can purchase this one or 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 this one. So if you'll do, you will get in total 12 ways. So basically in general, what property says if I have, okay, how many ways, in how many ways I can purchase a milk chocolate? 3 ways. And in how many ways I can purchase one dark chocolate? It's a force is nothing but total 12 ways. Is this clear? In general, if I say there is suppose a event A, for this occurrence of event A, there suppose there are n1 ways, and occurrence for another event B, if I have n2 ways, then there will be total to get A and B together, there will be total n1 into 2. Is this clear? If
Yes,
you
sir.
can extend in general also for 3 event, for 4 event, it will be n1 into n2 and 3 and 4 like that. Okay. Now,
Yes, sir.
let's come to one more thing. So let me introduce that factorial also. You know factorial. So factorial is nothing but n factorial is nothing but it's called n is denoting n into n minus 1 into n minus 2 up to 3 into 2 into 1. That's something mathematical things. It's called factorial. So I want to do 4 factorial. So it will be 4 into 3 into 2 into 1. What about 5 factorial? 5, 4, 3 into 2 into 1. So this is 5. If you see clearly, so this I can denote as 4 factorial, right? So this 5 factorial I can write as this one. So simply I can say n factorial nothing but n into n minus 1 factor, right? Same you can expand this one. 5 into 4 into, if you see these things, I can treat this as a 3 factorial, right? This is clear. This is regarding this point.
Yes, sir.
Okay. Now let's move to the next topic. Are you familiar with the, okay, suppose let me do one more thing. You know, are you familiar with the with replacement, without replacement? What is the meaning of with replacement, without replacement?
No, sir.
No. Okay, I will. Okay, let me create a scenario. Okay, suppose I have digit, let's say I have digit 0, 1, 2 up to 9. Okay, for example, suppose I want to, let's say 1 to 9 instead. Suppose I want to create a 4-digit password. Okay, and 4-digit password with repetition. Okay, let's say without repetition. What is meaning of without repetition? I cannot use the numbers or digit which I have used already. Okay. Suppose for make this 4-digit password, for the first place, in how many numbers you can use? How many ways you have to use?
9.
9. And for the second place, since I have put one condition, you can't use the same digit. So you will have remaining any 8 digit, right?
Yes, sir.
For third place, any
7.
of the 7. For the fourth place, any of the 6. Suppose I'm mentioning with repetition, means I can use the numbers. I can reuse the numbers. Then for the first place, how many ways I have? I can use
9.
any of the 9.
Yes.
Since I'm saying it with repetition, again for the second place, I have
Yes.
9 ways.
Yes.
9 ways, 9. Right? That's some rough idea. One concept called next is permutation. What is the permutation basically? So permutation is nothing but ordered arrangement. Here order actually matters. Ordered arrangement of the elements. Okay. What is meaning of ordered? Let's say. So let's say suppose there are 4 people in a room. Okay. And I want to choose 2 people, one people as a president and another people as a vice president. Okay, suppose there are 4 people, P1, P2, P3 in a room. So what is the meaning of ordered arrangements? So suppose I'm saying one president as one person as a president, another president, I want to choose a vice president. Suppose I have chosen P1 as a president and P2 as a vice president. Okay, so whether this order will be same as if I have said like P2, person P2 is the president, person P1 is the vice president. This order is same as this one or not? Is this order same? Suppose I'm saying P1 is the president in the first order and P2 as the vice president in the second time. Whether these two scenario is same or different?
It's not same.
It's
Different.
not same. It's a
Different.
different. That means order matter, right?
Yes, sir.
Okay. So permutations we can use in such scenario where order matters. Okay. And for formula for this is called NPR. So NPR, and we are denoting as is n factorial divided by n minus r factorial. Okay, basically. And one formula. Okay, how we are getting this this NPR? Basically, we have to arrange the R things out. What is the meaning of this? Means we are arranging R objects out of n objects, right? Here, what we are doing in this case, we are arranging 2 people out of 4 people. Got it? So you will get 4 factorial divided by n minus r, 4 minus 2, which is 2 factorial. So if you solve this, you will get 4 into 3 into 2 factorial, 2 factorial will get cancelled. I will get total 12 different ordered pair, like P1, P2, P2, P1, then P1, P3, P1, P4, then different thing, right? You will get in total 12. Is this clear? Meaning of permutation and order? Idea you are getting, right?
Sir.
Okay.
Please repeat, sir.
Where you got you did not get?
Please repeat this example, sir.
Okay, this example. Okay. So basically permutation is something we can use in that scenario where order matter. Order matter means, let's say I'm saying in a room there are 4 persons, okay, and I'm saying I have to choose or I'm going to arrange 2 people. Well, see, whenever arrangement is there, right? Ordered arrangement. Be clear with ordered arrangement means order matters. Then I'm going to use the permutation. Okay. Let's say I want to choose 2 people, and after that I want to arrange these 2 people at the position of president and vice president. Suppose person P1 is the president in one scenario and person P2 is the vice president, and consider another scenario, person P2 is the president and person P1 is the vice president. Whether this arrangement is same as this one, this order is same as this one? No.
No.
These two are different, right? So in such scenario, we can use the permutation. What permutation says? There is formula NPR is nothing but n factorial divided by n minus r factorial. So basically it's a R arrangement of R objects out of n. Okay. Next concept called, another concept is called combination. Notation for is this NCR. It's called N choose R. So combination is used when we are not considering about order. Okay. Whenever we are not considering about order, whenever we have to just do the selection of people or we have to choose the people without considering any order, then in that scenario, I'm going to use the combination. So for the combination, its the formula is n factorial divided by r factorial into n minus r factorial. This is the formula. Let's say I took that example, 4 person in a room, right? Now I'm saying I want to choose or I want to select 2 people from the room. Okay. Then in how many ways you can do? Suppose I have selected P1 and P2 or P2 and P1. So P2 and P1. So these two are same or not?
Yes, sir. Same.
It's the same because
Okay.
I'm not going to give them any order like president or vice president. I have just selected 2 person, P1 and P2 or P. Suppose I have selected P1 as first or P2 as the second or P2 as the first or P1 as the second, doesn't matter. At the final way, I have selected these 2 people, right?
Yes,
Correct
sir.
or not? So
Right, sir.
basically, suppose I have selected P1, P3. This is same as P3, P1.
Correct.
Yes, no?
Correct.
Yes, sir.
Correct. So in
Yes.
case of combination, we are not going to consider the order. That's why we are dividing by r factorial. Okay. If I'm going to, since what is this? This is nothing but NPR, right?
Yes, sir. Yes, sir.
Okay. So I'm not going to consider the order. I will divide by that factorial way. Are you getting? So if you
Okay.
use this 4C3, I will get 4 factorial divided by 3 factorial into 4 minus 3, it will be 1 factorial. If I will solve 4 into 3 factorial, 3 factorial. So I will get total 4 ways to select 2 people out of this. Okay. So, I mean, what are those 4 ways? Just a second. Let me zoom a bit. So what are those 4? It's a P1, P2 or P1, P3 and P1, P4 and P2, P4. That's all. No. One second. P1, P2. No, it's a 4C2, right? I thought what I made a mistake. Yeah, so it will be 4 into 3 into 2 factorial. So 2 factorial into 2 factorial, it will get cancelled out and 2 to the 4. So total 6 way, right? So it's a P2, P4. It can be P2, P3 and P3, P4. That's all right. These are total 6 possible combinations, right? Yes or no? In case of permutation, we have to consider reverse also. P2, P1. Suppose order is there, vice president, president. Then these two are okay. So this is the different from this one, right? This is not same. Same P3, P1. So we'll have total 12 ways, right? So what we are doing, going to do here, we have total 12 ways, right? And we are dividing by 2 factorial because of in case of combination, because this is same in case of combination, right? Are you getting? That's why in case of combination formula, r factorial is there. Is it okay? Is it clear to everyone?
Yes, sir.
Okay.
Yes, sir.
So I have NCR as n factorial r factorial into n minus r factorial. If I will multiply it by r factorial, then what you will get? I will get n factorial divided by n minus r factorial, which is NPR basically. So suppose in general, I have selected R people out of from N, and then I have arranged those R people in R factorial. This is nothing but NPR. Are you getting? First, I have selected R people, then I have arranged those R people, which is same as NPR. What is meaning of arrangement? You are giving some order arrangement. Is this clear?
Yes, sir.
Yes. No?
Yes, sir.
Okay. So this is the one of the concept, and think by the formula you can solve it. But what is the value of NC0 is 1, NCN is 1, and there is one more formula. I mean derivation behind it. Basically, that formula is nothing but it's denoted R factorial into n minus 1 CR minus 1 plus n minus 1 CR okay, is equal to R factorial into NCR. Okay, so this is the same. One second. So key thing is this is same as this one. If you solve this, if you apply this formula, NCR formula for this, and if you add n minus 1, then you will get this NCR. Okay, this is just a problem. So I have selected some question. Let's try to do that. Hope you will get the concept. Okay. So do your pen and paper.
Yes, sir.
Okay, so just read the question. What we are doing here, we have 5 dice, and those 5 dice are rolled simultaneously. Okay, in how many of the outcomes will the third and fifth die turn up a 6 or a 1? Okay, so just take 2 or 3 minutes and let me know what answer you are getting. Okay, so you will be able to know how you can going to use this. Okay. Are you able to do it?
Sir, should we solve like 62 into something, or we
No,
should?
just use the counting principle. It's a simple. Okay, don't get.
Sir, I have solved it in terms of combination,
Mm-hmm.
but I have not numerically solved it to the final output.
Okay, so it's a simple counting principle. Okay, it's a basic key thing. Okay, so sometimes see, don't go direct combination and permutation. I mean, it's good to know, you are familiar to use directly, but it's also good thing to start from the basic. Like, for example, so suppose 5 dice are rolled simultaneously. In how many ways the outcomes will the third and fifth die turn up a 6 or 1? Tell me, if I'm going to roll a 1 die, what are the possible outcomes? I will get 1, 2, 3, 4, 5, and 6. These are the only possible outcomes. Correct or not?
Yes.
Now, if it's saying in how many ways the outcomes will the third and fifth die will turn up a 6 or 1. Okay. Now, tell me one more thing. I have total 5 die. Correct? For the first die, it says third and fifth die turn up a 6 or 1. So it says for the third and fifth die, how many possible outcomes is there? Only 2, right? For the third and fifth die, it says we have to find out the total number of ways in which third and fifth die will turn up a 6 or 1. So for third die, I have only 2 ways, and for the fifth die, I have only 2 ways. Correct or not?
Correct, sir.
Correct. For the first, second, and fourth, I can get any of the 6 outcomes. Correct. And for like, so we have to just multiply, because I'm going to consider for all the 5 die. So if you multiply, you will get the 864 as the answer. Is this clear? Condition with the condition. Okay. Now come to the next question. There is a little bit, just a slightly difference in this formula. 5 dice are rolled simultaneously. In how many of the outcomes will either the third or fifth die turn up a 6 or 1? Initially, third and fifth die turn up a 6 or 1. Here it says either the third turn up a 6 or 1, either the fifth turn up 6 or 1. So what are the possible cases? You can make the cases, right? Did you get the idea? Clear? Are you getting the question, everybody? Yes, no, you can say, right? Otherwise, how I will know whether are you getting the right?
No, sir.
Yes, sir. Yes.
So basically, question says they are rolling the 5 die, right? Question says either the third die will turn up 6 or 1, or fifth die will turn up the 6 or 1. That's the case. So there are cases. Case 1 will be like this. Okay, case 1 you can assume like this. Suppose, see, I have total 5 die, correct? Now case 1, just consider third die turn up 6. So for third die, I have only one way. Correct? If I'm considering case 1 as third die
Yes.
turn up a 6, I'm just separating the cases, right? So for the third die, I have only one way, right? For the remaining, I will have 6 ways. See, for the first die, it can take any of the outcome. For the second die, it can take any of the outcome, fourth, fifth, because I'm not putting any condition here. Correct or not?
Correct, sir.
So it's a total 6 ways for 4 ways. Now, case 2, just assume third die turn up a 1. Then how many ways I can do? So third die turn up a 1. For this, I have only one way. I'm putting the condition for the third die is turn up a 1. Okay. For the remaining, I will have 6 ways. Yes or no?
Yes, sir.
Yes, sir.
Again, I will get 6 raised to power 4 ways. Now, so as you see, third die turn up 6 or 1. I have considered these two. Now I can consider for the fifth die also. See, if you are getting difficulty, so let me do this one. Let me remove this. Okay, tell me case 1, third die turn up a 6 or 1. So for the third die, how many possible ways we have? 2 way, right? For the
Yes, sir.
third, I'm
Yes, sir.
saying whether it will turn up either 6 or 1, right? For the remaining, I have total 6 ways. Now what I will get? 2 into 6 raised for 4 ways. Yes or no?
Yes, sir.
Consider the case 2. Fifth die turn up a 6 or 1, correct? So 1, first, second, third, fourth, and fifth die. So for fifth die, I'm saying turn up 6 or 1. So it for this I have only 2 way, and for the remaining, I'm saying it has 6 ways, right?
Yes, sir.
Yes, sir.
Okay. So what I will get here? 2 into 6 raised to 4 ways. Now, as you see the question, it says either the third die turn up 6 or 1 or fifth die turn up 6 or 1. Then what I have to do? I am saying either case 1 or case 2. So I have to add case 1 or case 2 or not,
Yes, sir.
right? So if I have to add case 1 or case 2, then what will be the total number of ways? 2 into 6 raised to 4 plus 2 into 6 raised to 4. That means total it will be 2 times 2 into 6 raised to 4. That means 4 times 6 raised to 4, right?
Yes, sir.
Clear? Are you getting the idea? By just turning the situation, you will get the different setup. Okay. Yeah. 4 into 6 raised to 4 is the correct answer. Okay. So this is nothing but r factorial and all. So you have to find the value of x for n is equal to 5 and r is equal to 2. So as I told you, this is nothing but what? NCR, right? Correct? It's a r plus 1 factorial as usual, and it will be as you can see, here is r minus 1 r, then it's a r, it's a r into it's a r and r plus 1, then it will be n minus 1, not n, it will be NCR plus 1. Okay, and as I told you, NCR into r factorial is what? NPR, correct? So it will be, so this quantity will be NPR plus this will be NPR plus 1, and just put the value and you will get value of n and PR, you will get the answer. In a way, you can just directly put the value of n is here, value of r is here, you will get the answer. But I have used this formula because it will give me some simplicity for me at the end, right? So next question says, let me take this question. You will get idea for this some sort of. So how many 3-letter words? Okay, be clear. With or without meaning, I'm not concerning about the meaning. I think from the 8 p.m. you guys have session, right?
Yes, sir.
Yes, sir.
Okay, so let's do this one. After that, rest of the thing we can discuss in another session. Okay. So how many 3-letter words with or without meaning can be formed using the letters of word vertigo without repetition? Be clear. Okay, means we can't repeat the letters of this word, such that condition says I is the one of the alphabet in each of the words formed. Means you have to form 3-letter words in which I is the one of the alphabet. Did you get the idea? Hello.
Yes, sir.
Yes, sir.
Okay, so in how many ways I can do? So first of all, I have to form the 3-letter words. I is the one of the alphabet. So just think, no, from the scratch. Means I have to form the 3-letter words, correct? I is the one of the alphabet. So I can be here, okay? Or I can be here, or I can be here. Right or not? Yes or no? Tell me.
Yes, sir.
Yes, sir.
For the second place, how many letters we have remaining? How many
Six.
letters?
Six,
Six, right?
sir.
For the third place,
5.
for the here I have already used I. For the first place, I can use any of the 7. 7 or 6?
6.
6 because I is already used and I can't repeat the letters, right? For the third is 5. Similarly, 6 and 5. So we have to use, okay. What is nothing but 30, right? 30, 30. So similarly 3 into 30, that's the 90. Which is the answer? Okay, it's the 6p2. So what is the 6p2? Because it's the I. For the 2 places, in how many ways I can arrange? I can arrange in 6p2 ways, because order will matter, right? Because if I'm using IVR or IRV, so these two are the different thing, right? Okay, so it's a, you can use directly 6p2, or if you solve the 6p2, it will be 6 factorial divided by 5 factorial, and it will be get not 5 factorial, 4 factorial. So 6, 5 into 4, 4 will get cancelled, I will get 30. Okay, which is the same. Either you can do in permutation by using permutation formula here, or you can do from the scratch. Is this clear? Idea is okay?
Yes, sir.
Yes.
Okay, then do you want to do one more question, or okay, let's do it. It's the same question, just a slightly difference. Just a slight change in the formula. Now you people will do it. Tell me the answer.
Sir, one doubt in the previous question, why we have taken permutation, not combination, because we are not considering order is considered. That's
Yeah, order is matters, right?
okay. Order
okay,
matters.
Okay. Tell me one thing. Suppose I'm writing the word cat, okay, or CTA. So is this same as this one?
No, sir.
Words are different, right?
Yeah.
Yeah.
So order is considered. So,
Yeah, order is considered, right?
okay.
That's why you can use P2. If you are getting difficulty in using permutation, just do the from the scratch. See, initially I have done from the scratch. I did not use the permutation, right?
Yes.
Yeah, okay. Okay, so just do this one. Be clear, there is a slight difference with repetition, and one slight difference. I use exactly once in each of the words form. I mean, you can use you can repeat the letters, but
Sir, is
not.
this 6p2?
Okay. No. Why 6p2?
Sir, because I will be in the first place only.
No. Exactly once doesn't mean you can use I at the first place. I see what question says. Question says I have to form the 3-letter words with or without meaning. Okay. Okay. Before going to, if I'm saying just forget this condition, I'm saying you have to form the 3-letter words with or without meaning by using these things. In how many ways you can do?
7 into 7 into 7.
7 into 7 into 7, right? Now, question, there is a twist. You can use I exactly once, not so. For there is a condition for I. I mean, you can repeat the letter, but not I. You can use the I only once. Are you getting?
Yes.
So I have 3 places, right? Suppose I is at the first. That means what? I for the second place I can use
7.
any of the 6.
6.
Any of the
7,
6.
sir.
No.
I exactly once. Okay, sorry, sir.
Okay, if I'm going to use I as exactly once, then I have remaining 6, right?
Yes.
For the second place, now I can
6.
repeat the letters again 6. Correct?
Yes.
Now suppose I is at the second place, then for this it's the 6 into 6. If suppose I is at the third place, it will be 6. So that means what we got 6 square, 6 square, 6 square. So it's nothing but 3 into 6 square. Is this clear? Just a small twist in the statement of the question. Answer are different, right?
Yes, sir.
Okay. Now I'm hoping you people got the idea, right?
Got it, sir.
So there are a lot of some more questions regarding these chocolates and all. Now we'll discuss it in next session because you guys have the Python session, right?
Yes, sir.
Okay.
Yes, sir.
So I hope you got the concept of permutation and combination, factorial and all. So rest of the things we'll try to cover up in the next. Okay.
Thank you.
Thanks everyone. Hope you got the concept.
Thank you so
Yeah.
much.
Thanks. Bye.
Thank you.
Thank you, sir.
Thanks. Bye.